And the last stop on our trip along the GI tract is the large intestine. And the large intestine is not all that large when you talk about length, but they're talking about its diameter again. So it's a lot bigger than the small intestine. The large intestine, all the digestion is really done by the time you get here. Small intestine has broken down your carbohydrates, your proteins, your fats, absorbed what it can, and really all that's left is the trash. So leftover pieces or debris and a lot of bacteria. The bulk, about 80% of all of the stuff that's in your large intestine is actually bacteria. It's not food anymore. It's the leftover products from bacteria eating and processing and breaking down little pieces and just replicating to fill your intestines. The bacteria really make the stinkiness of your intestines. The bacteria is there to do a lot of things like help release some of the last vitamins to help process hormones, and also it gives you gas, which isn't a good benefit, but certain bacteria produce a lot of gas, especially if they get too many nutrients. They can go crazy in there. So if you look at the large intestine, I can't click on it, there we go. You have where the small intestine attaches, right here at the beginning. So the ileum, the last section of the small intestine, opens up into what we call the ileocecal valve because the first part of the large intestine is the cecum. Right off of here is an interesting little guy called the appendix, and you've probably heard of it, and a lot of people have a problem with it. The appendix is considered to be a vestigial organ, which means we don't use it anymore. But at one time, a lot of people think that it was a kind of like your tonsils. It was a special catch place to grab infective agents, capture them, and kill them. So it has a lot of lymphatic tissue around it. Lymphatic tissue is full of blood and white blood cells to protect you. So we actually have a slice, kind of like this picture down in the bottom corner, in your slide of some lymphatic tissue, and we'll see what we see inside of it. Right. We're going to walk along before we look at that and look at here's the ascending part going up on your colon, so we call it the ascending colon. We have the transverse going across colon, and then the descending to the sigmoid, which means S shape, and then out of the body. The large intestine's main purpose is to collect the debris that's left over and squeeze it like you're wringing out a rag and pull all the water it can back into your body. And then it compacts the product of this, and then we call it feces. So the large intestine's goal really is to store bacteria to help get the last of any nutrients out that we can. Most of the major digestion is done. It's just getting things like vitamins or processed hormones, holding this feces until there's a place where it's appropriate to get rid of it, and then also pulling as much water as it possibly can out. And then the appendix is a little trap place. So let's go ahead and look at some lymphoid tissue, like your appendix. And we have one called the lymph node. Let me clean it off. Right. So lymph nodes are actually other places. You're not going to find a lot of solid nodes at the GI large intestine, but this is representative of what the tissue looks like. So if your appendix breaks, all these tiny cells can go into your abdomen, including the bacteria. So if we take a peek at it, let's switch over. There. Ooh. Pretty close again. There we are. It's lymphatic tissue. And you have two major regions of lymphatic tissue. You have some that's called the red pulp, and you have some called the white pulp. So the red pulp actually looks kind of red. It's a reddish paint color. Whoops, in here. Like this area, and then you have the white pulp that's more of a purple color because it actually stains your white blood cells. So the white blood cells are where the name white pulp comes from, and they're immune factors. So as blood and other materials come floating along here, all these white blood cells are setting up like ambushes and grab hold of and kill the invaders. Let's look a little bit closer at the two types of pulp. All right, so I just switched to my 100 times magnification. Wow, can you see that? All those little tiny cells already? A lot of red blood cells, white blood cells, and bacteria. There's an outer capsule that holds everything together. Here we got kind of a purpley mass. Right, so we can look at that. and you're getting a better picture with your naked eye looking through than I am with my camera. We're going to go up to the 400 times magnification. And you see lots and lots of cells that look like they're missing a nuclei. Do you see them? We can roll on. See what else we see. Going back and forth. There's a wall. You see that wall of tissue? They're dividing. And you can see lots of red blood cells. White blood cells. So there's some whites right there, the purpley ones. And I'm not able to increase and show you the magnification, but you can change your objective, or sorry, your ocular, and look even closer, actually double the size of each of those. And then we'll talk about the different white blood cells when we get to blood. But you can scan around and look, oops, at how many invaders there are, or invaders, how many cells are in here just waiting for invaders, packed with cells. It's like crowds and crowds. Blood vessels. Of course, because the blood's going to have to be transported through here to be cleaned. So many little tiny cells everywhere. Fat cells. And you have adventitia, the wrapper around. So just scan through, see if you can find some white blood cells, some red blood cells. And then you look specifically in the different types of tissue. Like, for instance, here's the white pulp, and here's the red pulp. So if you focus in, see if you can see the difference between the different cells. Which one has more of the white blood cells that are stained purple? Which one has more of the red blood cells that are stained pinkish red? Right? And that's the end of your path in GI tract. We have one more to talk about with comparative anatomy.